Hi, I'm Christopher, a research software engineer with Research Software Workshops, and it's a very warm welcome to part 3 of Text and Sentiment Analysis in R. The materials at the website below go to the Sentiment Analysis section and it will look something like this. Sentiment analysis involves trying to analyse the feelings or sentiments expressed within a piece of text. Now, sentiments could be interpreted broadly, so for example, words being classed as positive or negative, or maybe more nuance could be included, so maybe you're going to classify words as expressing joy or fear or sadness, etc. Now, sentiment analysis depends on building a dictionary of words and classifying those words according to the sentiment. Now, there are several such dictionaries that have been created, typically via crowdsourcing or some other kind of large-scale analysis. The Tidy Text library provides the Get Sentiments function, and this can be used to download one of many different sentiments dictionaries into a Tibble. Now, amongst others, Tidy Text provides access to 3 general-purpose sentiments dictionaries, AFIN, Bing, and NRC. Now, for example, we can maybe download the NRC dictionary by using the code that's here. So let's now fire up our studio. I'm going to create a new R notebook. Move down the console. Again, don't need the text that's here, and I'm going to call this sentiment.r markdown notebook, which I'll put into my workshops folder. Okay, so we're going to need to load up the tidyverse as we normally do. We're also going to need to bring in the tidy text package, which is going to contain the get sentiments function. And we're going to load up the NRC sentiments dictionary by using get sentiments and loading up NRC as here. If you wanted to do Bing or AFIN, you would type in their names at this point. And then let's take a look at what this Tibble looks like. Okay, so you can see that we have words, and the words have been multiply classified. So for example here, abandon is classified with the sentiment fear, and negative, and sadness. If we go forwards, above mentioned is positive, abortive is negative and sadness, abundance is anticipation and disgust, and joy and negative and positive, and trust. So you can see that each word is given, well, some words can be given multiple sentiments. And actually what this is just a dictionary of words with attached sentiments. Now note that this assignment of words to sentiments is based on individual words only, so it's not based on sort of joining words together. And it's also based on a fairly conservative modern usage of these words. So for example, badly, which I can try and find here, but I think it would take a bit of time, is classified as both negative and sadness. And in my opinion, that wouldn't really capture that correct sentiment in sentences like, I badly want that, or I'd say that's not a sadness or a negative. Equally, backwards is classified as disgust and negative, which is not how I would see it in sentences like, they skillfully drove backwards around the course. So you have to be sort of very careful and mindful when you're using these dictionaries that they're really created for the linguistic style that they were generated for, and they wouldn't really be applicable to other texts used with a different linguistic style. So do really think about whether or not these sentiment dictionaries would be applicable to your text. Also be very careful of license. So different dictionaries are distributed with different licenses, and there are maybe different obligations on their use, so for example citation or payment. So again, be very careful, just check what you're doing and don't just blindly accept what these things are saying. Now note also that different sentiment dictionaries will use different sentiments and may classify them in different ways. So for example, the NRC dictionary classifies in this sentiment column, and we can get a full list of all of the sentiments by basically just running a count on that sentiments column. So let's sort of bring up a new R block. So we're going to pass sentiments, which is the sentiments dictionary, through a count, and let's just count the number of times that we have an entry in each of the sentiment column. There we are, so anger appears 1247 times, anticipation, disgust, fear, joy, negative, positive, sadness, surprise and trust. These are the only sentiments that we have within this dictionary. And let's see, the most common one here is most of them are negative, then positive next, and then sort of fears, disgust, anticipation, surprise, joy. So yeah, use this to look at your sentiments dictionary and just be very happy with what you're using and be clear you understand what you're using. Now we can perform a sentiment analysis by attaching a sentiment to every single word in a block of text. So for example, let's now recreate that tidy text tibble of all of the non-stop words in the Adventures of Sherlock Holmes. So we did this in the last section. So we're going to basically bring in the Gutenberg library because we're going to be downloading this from Project Gutenberg. We need to bring in the stop words, which are provided by tidy text, so we can then remove them. And now let's basically build a Sherlock tibble, which will be a clean, tidy table of all of the non-stop words tokenized by word. So we're going to download Adventures of Sherlock Holmes as book number 1661. We're going to use unnest tokens again to tokenize by word and put that in the word column. We're tokenizing the text to the text column. And then we're going to do an anti-join on the stop words to basically remove those from this tibble. And then if we take a look at it, you should see we'll get back what we had in the last section. Sorry, unnest tokens. Must remember the S there. There we are. We now have the tidy tibble. Now we can classify each word by sentiment by joining together the tidy text Sherlock tibble with the dictionary of sentiments and the sentiments tibble. Now this is not an anti-join, this is now an inner join. We use the dplyer's inner join function. This will join together the two tibbles via their common column, which is the word column, and it will create new rows as needed if a word appears twice. So let's now run this. So we're going to take Sherlock, we're going to create this as the Sherlock sentiments tibble. So we're going to create this as the Sherlock sentiments tibble, and we're going to pass this through inner join. And because both our tibble and sentiments have this column called word, it will automatically join on the word. Actually, no, sorry. Yes. Let's see what this does. I think it will automatically pick up the right columns at this point. There we are, it's joining by word because we have word column in the sentiments tibble and we have the word column in our tibble. And so columns of the same name, it will automatically join by that name. So now you can see that we have added this new sentiment column to our tibble, which basically contains the sentiments for each of the words. So scandal now appears twice with fear and negative, mystery appears twice with anticipation and surprise, etc. So as you see, each word, this has added the sentiment column and repeated the words where they have multiple sentiments. And what we can now do is count how many words of different sentiments there are by filtering on the sentiment column. So let's take the tibble again. So we're going to take Sherlock sentiments and we're going to pipe this through a filter where now we can filter by the sentiment we want. So let's just take out now all of the positive sentiments, all of the positive words. So the sentiment is going to be positive. And now let's count them. So this has filtered all of the positive words. And then it's then counted the word column and we found that we have 108 occurrences of found, 79 of sir, etc. Now we could of course use this to count the total number of words of each type. And that's by using a summarize, which we've used before in the workshops. So let's take Sherlock sentiments. We're going to pipe this through the filter. Let's take now joy. This is now going to take all of the words that are classified as joy. If we count the number of words, if we now summarize this, so we just did the count on its own, like that, what would happen is we just get one tibble where And I think, oh, I've got a T here. I always make mistakes when I'm typing. There we are. So if we just did the count, we're just counting up the number of words, the number of occurrences of each joyful word. But if we now pass this through a summarize, it will basically summarize. We want to summarize this n column by summing it all together. So we do that by using summarize. And we'll say the total is equal to the sum of the n column. And if we do that, we can see there were 1,571 joyful occurrences within this particular text. Now, alternatively, and much more simply, if we just took the Sherlock sentiments tibble itself, if we just pass this through count, we can of course just count the number of occurrences of each sentiment. If we do that, we can do there, that's the 1,571 appearances of joy, but actually we've had 1,297 appearances of anger words, lots of anticipation, mostly positive actually in the book, so it's more positive than negative. There's more anticipation than there is sadness. Actually, we have quite a lot of anticipation and surprise in this book, quite a bit of trust as well. And of course, we can now plot this using a similar technique to the last section, where instead of now mutating the words into factors, we can mutate the actual sentiments into factors. So let's do this. So let's take Sherlock sentiments. Let's pipe that through the count of sentiments, just as we've done above. But now let's mutate that. So now the sentiment should be turned into a factor. So reorder sentiment with the count. And now finally, of course, we can put that into ggplot as we had before. And now the aesthetic is we want to put the count on the x-axis and now the sentiment onto the y-axis. It's going to be a column plot, bar chart, and we don't need to put the actual name of the y column onto the plot. So if we do this, there we are, we can see there we are. It's much easier to see things in a bar chart, more positive than negative, and trust, anticipation, fear. That, to me, that sort of sounds like a Sherlock Holmes book, and I hope you would agree with that. So okay, what that's done is we've now basically worked through all of this part of the workshop. We have now got to the exercise, which is, here we are, and I'd like you to perform a similar sentiment analysis for your chosen book from Project Gutenberg. How does the number of words of different sentiments in your book compare to that for the Adventures of Sherlock Holmes? And does this difference match what you would intuitively expect from your choice? So press pause, have a go at it, and when you come back from pause, I'll show you an answer. Okay, you've now come back from pause, so I'm going to work through an answer, and I'm going to use basically the Hound of the Baskervilles again. So let me put this in. Again, you'll need to have made sure that you have imported tidyverse, tidytext, Gutenberg, and also put in the stop words. So I'm going to load the Hound up as I did before. So that's going to be a Gutenberg download. And it was number 2852. Going to pipe that through because I need to tidy this up. So I need to put this through on this tokens. We're going to tokenize the word into the word column from the text and the text column. We're going to then anti-join with the stop words because we don't need them. Now, of course, we need to get the sentiments dictionary. I've already loaded the sentiments dictionary, but I'm just going to sort of pick this up again just so you can see the code. So in this case, we're going to take the NRC sentiments dictionary, and I can then build the sentiments tibble by performing an inner join between the Hound tibble and the sentiments tibble, and that's because they both have a column called words. Now that I've got the sentiments attached to every single word in the Hound of the Baskervilles, I can graph this by basically taking Hound sentiments, piping it through a count, so we can count each sentiment itself. We'll then mutate those sentiments from being text to being factors so that they can then be plotted nicely. And then finally, we then put this into ggplot with the aesthetic that we're going to place the number of occurrences on the x-axis, the sentiment itself on the y-axis. It's going to be a bar chart, and again we don't want to label the name of the y-axis. So hopefully if I now run this, I've not made any mistakes. There we are. So again, mostly positive, the negative, trust, fear, sadness, anticipation. Yep, that kind of fits with The Hound of the Baskervilles, in my opinion. It's a slightly sadder book, I would say, compared to overall. This is trust, anticipation, fear, sadness. This is trust, fear, sadness, anticipation. Okay, so now that we've completed that exercise, we're now going to move on. So what we'd like to do now is we want to basically investigate how a sentiment might change throughout a text. Because obviously what we've done so far is we've looked at the sentiment in total, from the entire text. So maybe in a text you'll find that it will start sad and then it will get a little bit happier, or it might start happy and then get sadder. So again, by plotting the change in sentiment through a text, you might get some insight into the narrative structure of the text. So to be able to do this, we need to add a line number to every single word in our text. And this means we need to mutate the tibble that was downloaded from Project Gutenberg and add the line number column, which is just the row number from the tibble. And so that's basically, we can do this as like a really useful function called row number. And that row number will basically count the row number for each row that came from the tibble itself. And so by adding in this one extra line here, what this is doing is saying it's mutate the tibble we get from Project Gutenberg, add a line number column, which is just the row number. And because we know the row number is the line number from Project Gutenberg, that works really well. So let me do this in RStudio. So I'm going to download again the Sherlock book. Gutenberg download. This is book 1661. But now I want to mutate it. So we're going to create a new column called line number, which is just the row number. Very easy. Now that I've done this, I can then unnest tokens, where we're going to put into the word column each individual word. We're unnesting the data in the text column. And then finally, I'll do an anti-join to get rid of the stop words. And then just to show you what this looks like, I'll just show you this tibble again. There we are, let's run this. Hopefully I've got this right. There we are. So now you can see here is the line number column, and these three words are on line 1, these words are on line 5, then line 9, etc. And obviously there are lots of blank lines, if you remember correctly. That's why we don't have lines 2, 3, 4, etc. here. Now that we've done this, we can now add in the sentiments as we had before. So we can take Sherlock sentiments, which we're going to build by taking Sherlock and then running that through the inner join with the sentiments tibble. Again, I'm going to show you what that looks like. So there we are, we have the sentiment column has now been added to this tibble. What we now want to do is we now want to count the number of words with different sentiments for different blocks of the text. So we could do this line by line. We could say, well, there's one positive and one trust on line 5, then one fear, then one negative on line 9. But if we do it line by line, then there isn't really enough text to show sort of like lots of appearances of words of sentiment. So what we ideally want to do is block the text up. Now we could block it up by page or by chapter, but unfortunately we don't have that information available in this tibble. So the next best thing is to block it up in blocks of lines. So let's say in the first 80 lines of the text, then from lines 80 to 159, then from lines 160 to 239, etc. So if we block it up by blocks of 80 lines and then count the number of sentiments in each block, we can then track sort of the evolution of the sentiment through the entire narrative. Now we can divide into block by using this, and I'm going to sort of type this in, show you how it works. If we typed in line number percent less than percent 80, what this is doing is it's actually doing modulo division. and that will divide it by 80 and give you the remainder. So how many times you can fit 80 in. So basically this would mean from line 0 to 79, 0 to 79 modulo divide 80 is 0, whereas 80 to 159 modulo divide 80 is 1, because there's 180 that can fit into it. Then 160 to 239 modulo divide would be 2, because you can fit two 80s into that. So to use this modulo divide, we need to mutate, we need to use the count system, but now we're going to count with block. And we're going to create that this way. So if we do Sherlock blocks, we're going to create this as a tibble. So we take the Sherlock sentiments tibble. And now when we count, we're going to create the column. It's going to be a new column called block, which is going to be the modular divided of the line number by 80. And then I want to count the sentiment that we get there. So it's going to create a new count column and also this new block column. If we now look at Sherlock blocks, see what this has done. There you can see now it's counted it by block. So block 0 are all of the words that have appeared in lines 0 to 79, and here are the counts of those words from 0 to 79, or counts of appearances of those sentiments from 0 to 79. Then in block 1, these are lines 80 to 159, and here are the counts of the sentiments from 80 to 159, etc. So this is a way of using count where we're not counting across the entire tibble, we're counting it in blocks, in groups effectively, across the tibble. So again, really very, very useful. So now that we've counted by block, so by sections along the text, we can now pivot the tibble so that the sentiments are the columns, and we now have one row per block of text. So at the moment you can see the sentiments here are rows, and so in block 0 is appearing multiple times. What we ideally want is basically block 0, because that's our observation, and then each element, each variable will be the sentiment going along as columns. So to be able to pivot the table, instead of pivoting it longer, we're now going to pivot it wider, and so we'll use the pivot wider function, which comes from the tidier package. So I take Sherlock blocks, and that's now going to be taking the Sherlock blocks tibble, and we're going to pipe this through pivot wider. So what pivot wider will do is it will basically take a long thin tibble and it basically rotates it to become a wide tibble with lots of columns. Now the names of the columns, so we want the column names to be anger, anticipation, disgust, fear, joy, negative, positive, etc. Those column names are coming from this sentiment column. So names from is going to be sentiment. Now the values, so how many they should appear within each column, the values for each of those are going to come from this n column. So we want the anger column for block 0 to have value 7, then the anticipation column from block 0 to have value 21. So the values are going to come from the n column. Now, occasionally there'll be sentiments which don't appear at all within a particular block, so I don't see any. There is surprise actually, but I don't see, there might be some missing here. And so where a sentiment is missing in a block, we want it to say set the value to 0. And so we do that by saying values fill and then saying what is the default value, and the default value we're going to say is 0. So if we now have a look and see what this has done. There we are, you can now see we've rotated the table, we've pivoted the tibble. So now we have the sentiments going across as columns, and then the counts are sort of set up nicely. So you can see here block 0 has 7 anger, 21 anticipation, 6 disgust, 13 fear, etc. It's much easier to read like this, because remember now our one observation is the block number. Now that we've pivoted it this way, we can do things like calculating the difference between the number of positive and negative sentiments in each block, which could be placed into a new column, for example called sentiment. So we're going to do this using a mutation. So in this case we'll take Sherlock blocks, and we're going to mutate it, where we're going to create a new column called sentiment, and that new column called sentiment is going to be equal to the difference of the values in the positive column from the negative column. Again, if I now look at Sherlock blocks, you should see that we've now created that new column. And I thought that should work. Let me see what I've done wrong. Oh, positive. There we are. Positive, not. This is one of the things with R errors. You're sometimes like, what have I done wrong here? There we are. So it's positive minus negative, not positive minus negative. And now if we now look across, there we've now added this new sentiment column. And this new sentiment column here is giving us the difference between positive and negative. So 40 minus 23 is 17. Here, 40 minus 15 is minus 1. So we can see the track of the difference between positive and negative through block number. Now, of course, we could then graph this with the sentiment column on the y-axis and the block number on the x-axis. So let's do this now. So Sherlock blocks. We're going to now put this into ggplot. And now the aesthetic is that we want to have the block number on the x-axis, the sentiment value, so the difference between positive and negative on the y-axis. And again, we'll just use a geom col, make a bar graph of this. Very simple. So there we are, we can see we start off broadly positive, and then as the book progresses, we have more dips of negative. Now we can also look at the trajectory of specific sentiments within the book. So for example, we could look at maybe joy. So if I take here, take Sherlock blocks, and I can of course just plot the progression of joy through this particular book. So again, just ggplot. In this case, the aesthetic will have block on the x-axis, but now we want the joy column on the y-axis, and then we'll just draw a column graph of that. Yeah, so we have little peaks of joy, but it looks relatively the same. Towards the end, it becomes much more joyful, I think, at the end of the book. So that's now taken us through all of this section of this particular page of the workshop. We've now reached the exercise at the bottom. There's 2 of them. I'd like you to draw a graph of the difference between positive and negative sentiments for your chosen book. And then I'd like you to explore different number of lines within each block. So basically, if you change the block number, will it change your graph that much? So again, have a go, put me on pause, and when you come back from pause, I'll go through this myself as well. Okay, you've come back from pause, so I'm now going to basically take you through an answer. Again, these are always an answer, that doesn't have to be the answer. There are many different ways you can do these things. So I'm going to do this at the bottom. Again, remember you will have to have imported tidyverse, tidytext, Gutenberg, and also put in the stop words. But in this case, I'm going to bring in hound, do the Hound of the Baskervilles again. Gutenberg download, I'm doing book number 2852. In this case, I'm going to pipe it through unnest tokens, word and text. So that's, forgot I need to mutate it first, of course, because we must add in the line number, otherwise we won't be able to track progression through the book. So we're going to mutate it where we add in the line number is equal to the row number from the tibble. Okay, then we can use unnest tokens on word and text. And then finally we'll anti-join with the stop words. Okay, now we've done that, we can now do an inner join to build a sentiments tibble. So in this case, we're going to take hound. We're then going to do an inner join with sentiments. And then we're going to do a count again, because in this case, let's count it all into one line. So count, we're going to make the block column is going to be the line number column which has been modulo divided by 80. And then we're going to count the sentiments that's there. Okay, now that we've done this, we now need to pivot the table wider. So then we have the sentiments themselves are columns rather than rows. So in this case, we can do pivot wider. We take the names from the sentiment column. The values are coming from our M column. And we're going to fill any missing values with a 0. Now that we've done this, we can now basically take hound sentiments, and we have to basically add in this extra column where we're going to say take a sentiment column, which is the difference between positive and negative. So we pipe this through mutate, and this is going to add this new sentiment column, which is equal to the difference of positive minus negative, and I'm going to spell this correctly this time. And then finally we can put this into ggplot. We're putting an aesthetic where block is on the x-axis, sentiment is on the y-axis, and we'll just do a geom-col, a bar chart. So hopefully when we run this, there it all kind of looks good. Now let's say we want to play around with the block size. What I can do is I can take all of this text again, maybe from this point, because this is where we put the block in. Now if I want to play around with the block size, one way I could do this is create a block size variable. So set that equal to 50. And now here, instead of doing block equals line number divided by 80, I can do line number divided by block size. So let's try a block size of 50, and now let's run this through. I've got an extra 3 dots there. And now if we run this, there we are. So this was the first graph. This was this one. Let's try with a block size of 150. What does that do? Yeah, I think we still get roughly the same kind of shape. I think if we try and make this too large, yeah, you still get this dip at the bottom, so it's relatively robust what we were doing. So okay, that's now completed both of the exercises. I hope you enjoyed this, and I look forward to seeing you in the next part of the workshop.